All right, so back to articulations. It's going to be a little different, as I was saying, because it's not just a list of structures you have this time. That is a component of it. But you'll want to go into Canvas, and maybe I'll just share my screen with you real quickly. Okay, so you can see that now. So under articulations here, there's going to be this lab introduction. And we'll kind of follow this as we go today, but you'll notice out of these 7 different things, it's actually only number 7 where you're identifying structures off of the list. These items 1 through 6 are going to be a little different. So it's going to be like name and identify 3 structural classes. So that's not really a structure, right? Structural classes, or the 3 functional classes of joints, providing examples of each, and describe the basics of fibrous, cartilaginous, or synovial joints, be able to differentiate between those 3 and provide examples of each of those. So just keep that in mind. I think it's going to be, whereas other weeks, maybe not as important to print off these introduction pages, this is going to be pretty necessary. So bring this up on Canvas, kind of check it off as you go. And again, we'll work through these items as we move through the lecture or presentation today. But as always, you do have a structures list, but it's just number 7 on there. All right, so let's start with item 1 here. Let's go with name and identify the three structural classes of joints, providing examples of each. So I'm going to go ahead and bring up my PowerPoint here. What's nice about articulations, however, is that they're a little more intuitive. And as I just mentioned, there are fewer structures. So it's not just going down a list of structures. There is an intuitive component to this. So I think it'll just, run through this lecture or this recording a couple times, and I think it'll really help. So let's begin with articulations. What are they? Well, it's a site where 2 or more bones come together, just where 2 bones come together. And there are different functions of these. The first is going to be to hold the skeleton together. Okay, that's pretty important, right? It also, because they articulate, it helps gives the skeleton mobility. Note that joints are the weakest part of the skeleton. So I'm going to do something a little unorthodox here and bust out my pen. A little more helpful when I have my pad, but we'll just do this. So they hold the skeleton together. So this involves stability. You're rough writing with your mouth, but stability. And they give us mobility. So that's what allows us to move, makes the skeleton movable. So if we think about this, we can kind of picture, it's a different way to show you what I mean, in a figure form. So this is not a drawing of a joint, but it's to represent. So on one end, we can have a joint that is highly mobile, right? And in fact, what we typically think of as joints within our body are the highly mobile ones, right? We can swing our arms around. We can swing our legs around, okay? But there are also those that are not mobile, and they provide stability, and they're very stable joints, and they have very limited mobility. And then there's everything in between. So down on this end, we can have a joint that has no mobility, right? You can see there's not much here, but has tons of stability. And then the far end, something like our shoulder joint or something. High articulation, but not much stability, right? know that people are constantly getting their shoulder pulled out of the socket, right? So it's a very mobile joint, but doesn't provide much stability. And then we have everything in between. So that's what we'll move on and talk about. Mobile joints, stable joints, and everything in between. Okay. Also, because they're the weakest part of our body, we see a lot of joint injuries. Joint injuries are probably one of the most common types of injuries for athletes. So as I mentioned, if you turn to that introduction page, we have both structural classification and functional classification of joints. So when we're talking about structural classification, we're talking about what is binding the two bones together, okay? Remember, an articulation is where we got two bones coming together. And the material that binds them is what defines them structurally. Also, whether there is a joint cavity or not, okay? So the different types of structural joints are, they can be a fibrous joint, cartilaginous joint, or a synovial joint. And these all have kind of different amounts of mobility. Okay? So let's take a look at this image here. A fibrous joint. So this is where we're going to hold two bones together, like all joints, but they're immobile, so they don't move, or they're slightly mobile. Okay? An example of this, a great one, would be the sutures within the skull. Right? So that's a type of fibrous joint. And we know that that's an immobile joint. Hopefully the sutures within your skull aren't moving. Okay. Next up, we have a cartilaginous joint. And these have great resistance to compression. Okay, so we tend to find them in areas where we see a lot of compression. An example of that then would be they're showing here between the vertebrae, so intervertebral joints. And then finally, highly movable, what we tend to think of when we think of as joints are these synovial joints. And those are the ones you're familiar with, right? Like your shoulder or your hip joint. They provide a large range of mobility. Okay. So that's the structural classifications based on what's holding those bones together. But we also have functional classifications. And this is where we talk about the amount of movement that they provide. So you can see how structural and structural and functional classifications could be kind of related, because you could have a fibrous joint which has limited or no mobility, or a synovial joint which has, freely movable. So the three functional classifications of these joints are synarthroses, amphiarthroses, and diarthroses. So if we just break down those prefixes, we can kind of look at what they do. Syn, that prefix SYN, means together, or together. And you can picture these bones as being tied together by these joints. So if they're tied together, syn meaning together, they're immovable. Okay? It doesn't allow any articulation. Then we have amphiarthrosis. A lot of you probably know that amphi means both, right? You've got amphibians, named so because they can live on land and water. Amphi meaning both. And that means here, in this context, if you have amphiarthrosis, it means they're both movable and immovable, or what we call slightly movable. So they give a little bit. And then we have diarthroses, which are just freely movable joints. And again, those would be like our shoulders or our hips. All right, how many times am I going to swing my arms throughout this presentation? Okay, so to kind of break this down, as I said, these are kind of related, right? Look at this another way. So we have our structural classification here on our left and our functional classification at right. And just to recap, we have fibrous, right? So like sutures in the skull, cartilaginous, maybe between the vertebrae, and then synovial joints, hips, shoulders. And we'll see then, if we line this up with functionality, we'll see that fibrous joints tend to be synarthroses, right? The sutures, syn, tied together. So that means they're immobile, immovable. With cartilaginous, this tends to, more often than not, line up with amphiarthroses. So remember these areas that experience compression, right? So maybe vertebrae, amphiarthroses, they move a little bit. And then synovial are highly movable, diarthroses. So we can kind of draw this relationship here. And you might want to take this down your notes or just review this lecture later. It's being recorded because this is a slide I added in. So usually I draw this out on the board and I don't have that. I should have brought home my whiteboard. That would have been good. But anyway, we see this type of relationship here. But there's also this relationship that exists. So it's not quite this cut and dry. Fibrous to synarthroses, cartilaginous to amphiarthroses. But we also do see some fibrous joints that show amphiarthroses tendencies and cartilaginous joints that are synarthroses. But synovial joints are always the freely movable diarthroses. Okay. And that's due to the presence of that joint cavity with these synovial joints. Okay. They're filled with synovial fluid, allows things to move around freely. All right, this is going to be an important slide for you. I don't know, suppose you got this PowerPoint available up on Canvas. You can just screenshot this or pull the slide out if you'd like to help you study. But this is nice because it ties together everything we're going to talk about, right? So we have our structural classification here on one end, and then we have our functional classification on another. And so it's going to give us, let's just go through fibrous joints here. So that's our structural classification. The fibrous joints, they're tied together with, fibrous tissue that allows no movement or little movement. Oops. And an example of that we said would be, well, let's just go with gum phosis. So that might be a new word for you, but you'll remember it because gum, G-O-M, looks like gum, right? And it's where your teeth are within the gum, within that socket within your jaws. Okay. And you have these periodontal membranes, which we'll look at shortly, that hold that tooth within that socket. So gum phosis. This is a type of fibrous joint. Thankfully, it's fibrous. Remember, these tend to be immobile. Otherwise, our teeth would wiggle around. Okay. And that is an example of functional classification, synarthroses. Syn, remember, again, being together. They're tied together, does not allow for movement. So this is going to be a helpful table when you work through these different structures. Okay. You'll notice here, again, that synovial joints are always freely mobile, diarthroses. All right, so let's work through these structural classifications, and we'll kind of touch on the functional classifications as we work through them again as well. Just kind of reiterate a lot of stuff I just said, but that'll help with you learning it. All right, so our fibrous joints, these bones are connected by fibrous tissue. So there's no joint cavity. So remember, we have the joint cavity with our synovial joints. We have synovial fluid. You've probably heard of synovial fluid before. And the amount of movement depends on the length of connective tissue. So remember, these fibrous joints can be immobile or a little movement, amphiarthrosis. So an example of something that would be immobile, thankfully again, are your teeth. And here are those periodontal membranes that secure that tooth within the gum. They're these little structures right here, okay? And remember, that's the gum phosis, okay? So that's a fibrous joint, holds your teeth in. And then the other example we talked about are these sutures. So we have gum phosis, an example of a fibrous joint. Suture, an example of a fibrous joint. Again, no movement. We don't bones of our skull moving around. But then a fibrous joint that exhibits syndesmoses, oh, this is called syndesmoses, sorry, was going to be the radius and the ulna. And this exhibits amphiarthroses. Remember, that's a little bit of movement. And we said it's based upon the length of the connective tissue. So we can see very, very small length of connective tissue in both the gomphosis and the suture. But here, all this connective tissue between the radius and the ulna called syndesmosis, or we call it the interosseous membrane, interosseous between bone membrane. And you can see this is longer bands of connective tissue. So that allows for a little bit of movement, which we call, again, amphiarthroses. So it depends on the length of that connective tissue within that fibrous joint, whether it's immobile or slightly mobile. What else do I got here? Good for that. So let's move on then to the second structural classification, and that's going to be these cartilaginous joints, which we said are very good with compression, right? So they have cartilage, which connects articulating bone, okay? And these joints, again, can be immobile or slightly mobile, just like our fibrous joints. Now, the cartilage within cartilaginous joints can be two types of cartilage that usually in past years we've kind of talked about a little bit by now because we go through histology, but I don't have that component just yet. So they can be hyaline cartilage or they can be fibrocartilage. Now, depending on when you have the lecture portion of 325, you might have gone through some of the stuff like hyaline cartilage, or some of you are working through block B right now and you're learning about this. Hyaline cartilage is, well, you're all familiar with it because it's kind of at the ends of the bones there, so at the heads, right? If you've ever had like chicken wings and you pull them apart and you have that shiny, reflective, smooth, slippery cartilage right there, that's an example of hyaline cartilage. So we see it a couple of different places within the human body. And one of them is going to be at the epiphyseal plate, so in the long bones. So this is the metaphysis right here of the bone, and that's where growth occurs. And we have hyaline there. So you can guess that, well, our bones hopefully aren't shifting around between the shaft of the bone and the head. So this is going to be an immobile joint where we see the hyaline cartilage here in this cartilaginous joint. And again, helps with compression. Okay. What else? And the other place we'll see it here is at the costa. Okay, so this is all hyaline cartilage here. Costochondral joints, and also immovable, right? But then, so these are synchondroses. And then we also have symphyses. So these are the two different types of cartilaginous joints, synchondroses and symphyses. Symphyses, well, I guess we haven't really seen before because we haven't gone through this. But one, we've talked about the pubic bone of the pelvis, okay? Here you'll see fibrocartilage. Fibrocartilage is this really tough cartilage, okay? It's got lots of chondrocytes in it that make up cartilage. So it's not this hyaline cartilage, but it's also really good with compression, okay? So areas that would experience a lot of compression, and this is more so associated with compression than is this hyaline cartilage. This isn't really compression, I shouldn't have said that. And we'll find it in places then like between the vertebrae, okay? These intervertebral discs, the joints there, they're made up of this fibrocartilage. So this is really great for compression. So these are immobile. I'll abbreviate that because it's going to take forever to write. And these are amphiarthroses. Ugh. Okay, so they allow for a little bit of movement, and again, great with compression. So those are our cartilaginous joints. Then that leaves us with the joints we're all familiar with, the synovial joints. Oh, my car is done. I have it dropped it off at the brake place today because I need new brakes and they're calling. Anyway, synovial joints, hips, shoulders, what we tend to think of when we think of joints. And here we get articulating bones, and they're separated by a fluid-filled joint cavity. And that joint cavity contains synovial fluid. Okay. So I'll just work through the components of the synovial joint right here. What we see associated with these is what we call an articular capsule. Okay, so it's this capsule around the ends of the bones that allows for articulation, the synovial joint. And this is made up of two different things, this articular capsule. First, we have this outer fibrous layer. I've called it in the past, I kind of compare it to if you were to take that joint and wrap it with a couple layers of saran wraps, just containing everything in there. So it's this outer fibrous layer, provides strength, durability, containment. And then we have this inner synovial membrane, okay? And associated with that synovial membrane, we get synovial fluid that comes from the epithelial tissue. And that's gonna fill this joint cavity right here. So this cavity actually isn't empty, right? It's filled with synovial fluid. I don't know, I'll give you a chance to talk here. What do you think synovial fluid is going to allow for within that synovial joint? If anyone wants to pipe in, you can unmute yourself or even just type in the chat, I suppose, if you'd like, if I can get there.
Can you clarify what you mean by what it's going to allow for?
Yeah, if you have two ends of bones coming together and they're surrounded by this fluid-filled cavity, what would the fluid, I guess, what purpose would the fluid within that cavity serve? If you can come up with anything.
Would it prevent like part of the bone-on-bone rubbing with the joint?
Great, yep, it reduces friction, perfect.
Absorb shock, like if you were to hit your joint.
Great, shock absorption, that's a big one. Those are probably the two biggest ones. Reduces friction, shock absorption, and kind of just keeps everything lubricated in there. We get bone on bone. I guess that's reducing friction as well, right? Some other things that it does as well is it helps with removal of wastes within that area. There's actually no blood supply to your joints. So actually just movement, like for example, getting up and moving around and moving that joint along helps move nutrients into that cavity as well as wastes out because there's no blood supply that does that for it. So, all right, thanks. Good job. So that's your articular capsule. And then let's move on here. So as you can tell, we're kind of just moving through this. Here, I'll close this out for a second. Just working through this list here. So we've gone through 1 and 2. Now we're doing basic structure of fibrous, cartilaginous, synovial joints. Okay. And then we'll just work through these as we go. But that's an example of how you can study this here. More on synovial joints. What do I got here? So for example, in terms of ID, you'll see that one of the things on your list is oh yeah, okay. Describe the basic structure of fibrous, cartilaginous, and synovial joints. So here we're going through the structure of synovial joints. So you need to be able to ID these kind of generic components here. So on your list of structures, you may see some of these of which you should be able to identify. Not all those are within there, but these that I've listed here, for example. So we'll start off with the articular cartilage. That's something we didn't really look at the previous slide, but we'll see here we have articular cartilage found here at the ends of these bones where they interact. Okay. And again, this is mentioned, it helps absorb compression, the cartilage in these areas. Okay. We have the joint cavity, which we said is filled with that synovial fluid. We have the articular capsule, which we defined on the previous slide. And then we have the synovial fluid. Okay, so it's a filtrate of the plasma. It comes out of these epithelial cells. And it does things we've mentioned, such as lubrication, reduce friction, nourishment for those chondrocytes. Chondrocytes are the cells that make up cartilage and absorbs shock. Okay. Now, there's also on your list here, it says number 5 on the introduction is differentiate between intracapsular and extracapsular ligaments. So these we have intrinsic ligaments, and these are what help form the joint capsule. So they kind of be like an extra layer of that saran wrap around the joint capsule that actually forms the capsule. Okay, but then we have these extrinsic. So remember, intrinsic means kind of like part of, and extrinsic means not part of. So that's how we can remember that. So if it's extrinsic, it's not making up that joint cavity, it just kind of is associated with it, but it's not structural for that cavity. Okay, so they're outside of that cavity. And I guess I'll give you some examples on the next slide. Actually, I'll just go ahead and flip there right now. So intrinsic ligaments, these are going to help make up that joint cavity. Okay, so we can see these here. Extrinsics, they're going to be outside. They're separate from the joint capsule, and really they're with reinforcement of that joint. Okay, so that's the difference. Manny, actually, I said he just emailed me. One of the things is you just need to know the difference between the two for this practical, so not too terrible. Some other things you should be familiar with here. Let's see. Well, we got these fatty pads. That would be pretty easy to identify. Again, more cushioning there. We have the meniscus. Many people have heard of the meniscus. In fact, athletes, or any of you here, I guess you don't need to be an athlete. And this pyramidal shaped structure here. Maybe you've heard of people that tear their meniscus, and it's additional structural support for this joint. So it's like this wedge that sits in there and helps keep things in place. So you can tear that, and then you're not keeping things in place any longer. We do have these joints within, 110 that you can look at, and you can see a little triangle shaped meniscus there that adds stability. It's pads of connective tissue. Okay. Provides additional structure for those mobile joints. Sorry. And then we have bursa. You may have heard of bursa as well. Real quick story time. I was in, I think it must have been like the last week of 8th grade or something. We did a bike trip, and we biked from our school over to the lake, and one of my friends brought his water balloon launcher. So he had it in his backpack, and being 8th graders, we thought it was a good idea to launch rocks at sailboats that were kind of moored out in the lake. And so I got tasked with the one pulling it back, and then so I had 2 of my buddies holding each end, right? It was one of those 3-person water balloon launchers. So I pull it back, let go. One of my friends has his end twisted. So it goes forward, untwists, and then shoots right back into my knee. And all I remember is like this clear fluid just shooting out of my knee. So what had happened is I had kind of popped that bursa. Okay, pretty gross. Then bones were contacting one another, couldn't walk for a long time. And one of the teachers came over, and we told them that I slipped on the rocks while one of my good friends ran away and hit his water balloon launcher. Yeah, a nice diversion. So anyway, bursa, now you know, are fluid-filled pockets, and they're filled with synovial fluid. And we just talked about the things synovial fluid does, but here it's going to be important with cushioning and reducing friction. So you can picture the bursa. They show it here? Yeah, so you got this bursa here, reduces friction where tendons would slide over here. Another interesting area where we have more synovial fluid, not within the bursa themselves, but are these things called tendon sheaths. So you can see these like associated with the tendons within your hands here. They have synovial fluid, or little like bursa-like sheaths around them with synovial fluid, and it reduces friction as well. I guess a good analogy would be any cyclists in there. You have your your brakes or your gear shifters. So you have that cable that runs on your right with the wire inside. Okay, so you're just reducing friction by having that outer coating for those. Okay, through that. And that's going to bring us to the movements made by each type of synovial joint. So this is number 6 on that intro page. These are pretty straightforward. People generally don't have a hard time with these, and that's because, well, the movement kind of sounds like what it does, thankfully. We just pull out random, I guess, terms here or terminology. So I'll just work through these with you here. It's helpful if you practice them on your own and help learn. There's a couple new ones here perhaps, but we'll go ahead and define them. All right, so again, these are only for synovial joints, those highly mobile joints. So the first thing we're gonna go here is, I'll just demonstrate these as we go. You got flexion and extension, okay? So flexion is gonna be when you're decreasing the angle between two bones exit. So that's your neck, but you can also do flexion, flex your arm, okay? So you're decreasing the angle between your radius and ulna and your humerus, right? So that's flexion. Extension then would be widening that angle. So flexion, extension, okay? We can do that with all these synovial joints. So flexion, extension. You can also hyperextend, okay? So you can do it with lower limbs, upper limbs, or hands, right? So flexion, extension. 2 terms you're going to need to be familiar with here are, I might have mentioned previously, are going to be adduction and abduction. So really this is just kind of lifting and dropping if you want to think of it that way. So the way to remember this pretty easily, so if I'm standing up here, okay, see I got my arms at my side. If I'm going to abduct my arms, think of being abducted by aliens or something, right? That means up, away from your midline. Abduction moves away from your midline, and adduction moves toward the midline. Think of adding back to the midline. So abduct, adduct, okay? And this can be the midline of any structure, right? So we can have, I guess you can do, abduction of your fingers away from your midline, abduction, put them back toward the midline, adduction, okay? This is a good one. I usually go up to the board and demonstrate this one because if you try to draw a perfect circle on the board, you're going to form a cone, right? Like a 3-dimensional, think of the volume there, right? A cone. And the way this works with circumduction, circum meaning circular, think of circumference, the proximal end is going to remain stationary. So if you're drawing a circle, you can notice this end isn't moving very much, right? It's the tip of that cone. Whereas the distal end, my hand, is swinging around, making a 360-degree arc, drawing that circle on the board. So this is circumduction. What else do we got here? Of course, there's rotation, simple as it sounds, but 2 different directions. You can do a lateral rotation, okay? Moving out lateral, or toward the midline, a medial rotation, okay? Same thing with your foot, lateral, meaning outwards, away from midline, medial, toward midline. Perhaps some newer terms for you would be pronation and supination. So this one's pretty easy. Remember that our anatomical position, I told you last week, your hands are supine, okay? A good way to remember this is if you were have to carry 2 bowls of soup, you'd have to carry them like this. You wouldn't carry them like this. You'd be a terrible waiter, okay? So supination, if you supine, and then pronation would be the back. I always think of pronation as you never want to turn your back to something because then you're prone for attack, okay? So carry the soup, prone for attack. Supination and pronation. Depression and elevation, up and down, just anatomical terms for you there. You might have heard of this with your feet. So you got dorsiflexion, dorsal meaning toward the back, and then plantar flexion. Think of planting your toes. You plant them in the dirt, plantar flexion. So dorsiflexion, arching your toes up, plantar flexion. Okay. And then we have these terms for your feet. Instead of, I guess, supination and pronation, I think those would work too, but we tend to call them eversion and inversion. But you might have heard of, if any of you in here are runners or athletes, you might have heard of a pronated step, right? And it's just like with your hands. So if you have a pronated step, it's going to look like this. You're exposing the back of your foot. If you have a supinated foot, you'd be trying to flip it over to kind of somehow carry a bowl of soup with your foot, okay? So we can have a supinated step or a pronated step, and that's eversion and inversion. We tend to use these pronation, supination more than we do eversion, inversion. Okay. We have protraction of your jaw. Some of you that went through the painful experience of having some type of corrective headgear to correct your bite protracts your jaw. Okay. And then opposite direction, pulling backward, would be retraction. I guess this, I suppose this is worth noting here. Opposition means to have two structures cross over. And in fact, the only place we see this is the opposition of the thumb and the little finger. Not sure if that's important or not, but kind of neat fact. So those are the movements of synovial joints. Now let's get into the specific types of synovial joints and then the movements that they can complete. All right, so first we're going to go through, I suppose, movements within one plane. So that we call these uniaxial. Okay, so one plane, not two-dimensional. So first thing we have here is a gliding joint. Okay, and you should know these joints. I think Manny just said in that email. I haven't gotten a good chance to read it yet, but you should know these joints and then examples, anatomical examples of each of these. So, and I'll run through those now with you. A couple of good examples. There's the ones listed here, and then I may give you others as well. So, gliding joint. I think a good example of this. So you got one directional movement, linear movement, basically two. It's doing what it's saying. It's a gliding joint, gliding on top of each other. So they're saying here, you got your, yeah, this is the one I like to think of perhaps is the best example, your intercarpal joints. So remember your carpals? Those are all kind of like flat oblong bones. Those are all gliding joints. So they can all slide over one another here, okay? In, you know, one plane, right? Not moving in two planes. Another example then would be a pivot joint. And this is again in one plane, so we can just rotate. Perfect example of that we talked about, I don't know, 2 lectures ago, would be this dens here of the axis. Okay, remember your atlas sits upon your axis and turns. So we have this pivot joint here, okay? So we can rotate in one plane. And then finally we have a hinge joint. This one's pretty self-explanatory, right? This is going to be your elbows, one plane, can't really move it any other way. That would be terribly painful and it would break. And the same with your knees, right? If you twist your knee, then you're moving in 2 planes, but it's not supposed to do that joint. So that's a hinge joint, just like a hinge on a door. So elbow, knee. And we have bi and triaxial, so 2 and 3 planes. So the first one we're going through here is this saddle joint. My favorite example of this would be the thumb. Okay, so you got this trapezium here. Remember, that's one of your carpals. And then you have this metacarpal bone of the thumb. And right in between them on that trapezium is this saddle. And the thumb makes this swinging your legs over a saddle, right? Okay, so that allows for biaxial movement. So in two planes now, we can move this way. So if you take your thumb, you can move it this way. We can also move it this way. And that's provided by this saddle joint, okay? We have an ellipsoid joint. This is like a mortar and pestle. I like to think of it that way, right? So crushing something up. A good example of that would be your knuckles. There's a little impression and it fits in there like the mortar or the pestle into the mortar and allows for rotation, you know, two plane dimension at these joints. And then one we're all familiar with here would be, this is triaxial, so we can move, well, every way with this. We have complete free range of movement. And these are our ball and socket joints. So these are going to be, for example, your shoulder and your hips. You can swing those in any direction you want, right? There you go again, swinging my arms. Now, if we go to your structures lists, there are obviously a few you need to know. We'll flip to that here. Okay. So under intervertebral articulations, for example, we have these different ligaments. And I don't know, they seem pretty daunting because there's a lot of them. But fortunately, they're all just named for where they're located in relation to the vertebrae. So they're pretty easy. For example, let's start with this posterior longitudinal ligament. Okay, we can see here's a front view, an anterior view, right? And we can see it's behind here, the body of the vertebrae. So it's posterior and it runs up and down. So longitudinally. What else do we got? We got this interspinous ligament. Inter meaning between the spines. Here's our spinous processes of the vertebrae, and it's found between them. Interspinous ligament. We have a supraspinous ligament. Okay, supra meaning above or upon, and we can see that's exactly where this ligament runs. Is there anything else? Oh yeah, perhaps the easiest. Anterior longitudinal ligament. Anterior, so it's on the front, and it runs longitudinally. Being multiple choice, I don't think you're going to have much trouble with those. Again, on your structures list, you have the shoulder joint under synovial joints. A couple things you need to know there. Again, they're kind of named for the two areas. The ligaments are named for the two areas that they're kind of bringing together or connecting. So for example, if we look at this coracoacromial ligament, well, it's going to connect, you can probably guess, if you've been studying, you have your coracoid process, okay? And then you have your acromion. So it's going to connect the coracoid process to the acromion. So that's exactly what we're doing right here. Anything else we got here? Glenohumeral. Remember, we got the glenoid on your scapula, right? Right near where it's the socket where that humerus fits in. And then we have the humerus. So it's going to connect the upper part of the humerus to the glenoid socket. In fact, this is what it does.